Okay, what we have here is two different equations that are in slope-intercept form. So this is our slope, and this is our y-intercept. So this is our slope, and this is our y-intercept. Well, what we have is this one is equal to y, and this one is equal to y. Well, we like when both equations are equal to y because we can use it substitution. So if I know that this equation is equal to y, well, then over here I can plug in 3x plus 6 for y. So what I'm going to have now is 3x plus 6 is equal to 4x plus 2. So basically what I've done is I've substituted this equation in for y because it tells me that y is equal to this. So now I would just solve it like I would a normal equation with variables on both sides. I can't have variables on both sides, so I'm going to try to get rid of the smallest variable, which would be the 3x. I'm going to minus 3x to both sides. So that cancels out, and I'm left with 6. Now, 4 minus 3 is 1x plus 2. I'm still trying to get x by itself, so I'm going to minus 2 from both sides. And these cancel out, so I'm left with 1x is equal to 4. Now that I know that x is equal to 4, I can come up here and I can plug in 4 for this x, or I could plug in 4 for this x. So for example, if I plug in 4 for this x, it would be 4 times x, which would be 4 times 4, is 16, and then 16 plus 2 is 18. Okay, so on this one, y would equal 18. And if I took the 4 and I plugged it in for x up here, I would also have 3 times 4 is 12. 12 plus 6 is 18. So y equals 18 here, and it also equals here. So once you found out what your x is, you can substitute it into either equation and get the same result for y. So your solution would be your x is 4, your y is 18. So your coordinate pair where those two lines would cross would be 4, 18 if you were to graph those two lines.